Hi girls, this lesson is going over roots and the discriminant in quadratic functions. Okay, so to introduce the idea of the discriminant, first I want you to use the quadratic formula for these equations just here. So you should do it, but I'll also do it. So here the quadratic formula would be x equals negative b, so negative 5 plus or minus root b squared 25. Minus 4 times a times c, so that's 4 times invisible 1 times 4, which is 16, all over 2 times 1, which is just 2. So it's negative 5 plus or minus root 25 minus 16 is 9, all over 2. So that becomes, root 9 is 3. So negative 5 plus 3 is negative 2 over 2, which is negative 1. And negative 5 minus 3 is negative 8 over 2 is negative 4. So that's the two solutions for x there. So now let's look at b. X equals negative b, which is 6, negative 6, plus or minus root b squared, which is 36, minus 4 times a times c, so 4 nines are 36, over 2a, 2 times 1 is 2. So now look at the discriminant. We actually get 0 under the discriminant. Under the square root. And then so we get negative 6 plus or minus 0. So we're not adding anything. So just negative 6 on 2, which is negative 3. So we only get 1 root. Now if we look at the last one, x equals negative b, negative 1 plus or minus root b squared, which is 1, minus 4 times a times c. That's 4 times 8. Which is 32 over 2a, which is that. Now look what happens. Under the square root, we get negative 31 over 2. Now, girls, you can actually put square root of negative 31 in your calculator. And you should notice that it comes up undefined, an error. Because we can't square root a negative, because you can't get a real number that squares to be a negative. There is something called imaginary numbers that when you square them you get a negative, but that's not in this course. So the idea is there's no solution, or you can also think of it as no real roots in this case. Back here there was 1 root, and over here there were 2 roots. And they were also distinct. Okay, so that's something important to note. Now let's keep reading. Basically it says, in the quadratic formula, b squared minus 4ac tells us how many roots there are in an equation. We call this part of the formula the discriminant and denote it with a triangle. So that b squared minus 4ac, that appears inside the inside the square root. And now, let's have a look at those. Here, in this example, the discriminant was 9, a positive number, and that positive number ended up with 2 roots. And also, the fact that that number 9 was a perfect square, that meant that with square root of 9 became a positive, like a whole number, 3. So what was nice is that meant my 2 final roots were rational, okay? Over here, my discriminant was 0. And so the plus minus didn't work anymore, so we weren't plussing and minusing anything. Therefore, we only left with 1 root, negative 3. Over here, when the discriminant was negative, we got no solution, or in other words, no real roots. Okay? It's important that you never say, don't leave the real part out. Don't say there are no roots. There actually are roots, but they're imaginary. That's not in our course, imaginary roots. But so it's important, what I'm saying is you have to say no real roots, not no roots. It's very important. So basically what we've learned from this is, summarized, it's all here. If the discriminant equals 0, then the quadratic equation, which equals 0, it's important that it has to equal 0, has 1 root, or you could think of it as 2 equal roots. So that's in this example here. The discriminant was 0, So we got one root, which we can also call two equal roots. In a way, you could actually say that the roots are -3 and -3. We'll learn more about that when we consider the graph of a quadratic function. In the next line, if the discriminant is bigger than 0, ax squared plus bx plus c equals 0 has 2. Now that should say real roots. Apologies. This, not equal. It should say real roots. Okay, so if the discriminant is bigger than 0, it has 2 real roots. So back here, when the discriminant was bigger than 0, we had 2 real roots. So that makes sense. Now, when the discriminant is less than 0, it has no real roots. So over here, where we had a negative discriminant underneath, basically, we had no real roots because there was no solution. Now, what this means for the graphs, when there's no real solution, that means there's no x-intercepts because all these solutions correspond to x-intercepts. So in this one, when x is -1 and -4, remember, on an xy plane at -1 and -4, my parabola would go through those 2 points. Okay? And so it makes sense because there are 2 x-intercepts, there are 2 roots. Okay? Whereas here in this one, the middle one, I should say, for this one here, when we were to graph that at -3, the parabola would just touch the x-axis once, right there. And that's why it only has 1 root. In this last one, if we don't have any roots, that means we don't have any x-intercepts. The parabola would look something like this, where it doesn't hit the x-axis at all, which is why it doesn't have any roots. So, and that's explained down here as well. Basically, these graphs here are a possibility for 2 roots. So, when the quadratic has 2 roots, we can cut the x-axis twice. Both of these parabolas cut the axis twice. Okay, so also, these are called indefinite functions because if you have a look at it, look at this curve. Up here we're in the positive y values because we're above the x-axis, and over here we're also in the positive y values, but down here we're in the negative y values because we're below the x-axis. On the other parabola down here, we're also in the negative y values, and then up here, we're in the positive y values. So because both graphs are in the positive and negative regions, for the y values at least, the quadratic is called an indefinite function. So these ones where they have 2 roots, and therefore they're both positive and in the negative and positive y values above and below the x-axis, we call them indefinite functions. Now, if there's only 1 root, that's when we just touch the curve, as I showed you. And so now look at this one here. This one just touches it. So except for the point where it touches the x-axis, the whole parabola is above the x-axis. And for the other one, the parabola is below the x-axis except when it touches the x-axis here. So now, what is this a? In each graph there's an a is bigger than 0 and a is less than 0. Oops. So here a is bigger than 0. What's that about? basically, that's the a in front of the x squared function. So if the coefficient of x squared is positive, our parabola is concave up or like a smiley face shape. Whereas if the a is less than 0, so then coefficient in front of x squared is less than 0, then our parabola is concave down. If there are no roots, so this is when the discriminant might be less than 0. So I might write that down as well. So let's go back. In this example, for 2 roots, what's the discriminant? And I think we're talking about here 2 distinct roots. This is when the discriminant is bigger than 0, so make a note of that. And this particular type of parabola, this first one, is when the discriminant is bigger than 0 and a is bigger than 0 because it's concave up. Whereas over here, this one's when the discriminant is bigger than 0 because there's 2 roots and a is less than 0, so it's because it's concave down. Whereas on this side, one root, that means the discriminant needs to equal 0 because that whole square root part of the quadratic formula needs to go away. So I'm not adding or subtracting anything. Therefore, I only get 1 root. So that's when the discriminant equals 0. And so when a is bigger than 0, we're concave up and we look like this one red one over here. And when a is less than 0, we're concave down and we look like that blue one. Now with no roots, so that's when discriminant is less than 0, so we're square rooting a negative number, which is when there's no roots, there's no solution. If a is bigger than 0, we're this parabola here, concave up, but we're above the x-axis. Now, could we be concave up and below the x-axis? If we were like this, think about it, these arms would have to extend upwards forever, so we would end up touching the x-axis, which would mean there'd be 2 roots, which would mean the discriminant would not be less than 0. Whereas in this example, we're only considering the discriminant is less than 0. So the only way we can have no roots and be concave up is if the whole parabola is above the x-axis. Otherwise, we would have 2 roots. Over here, the discriminant is less than 0, so there are no roots, and a is less than 0, so we're concave down. And we can't have that above the x-axis, because if I was above the x-axis, I would extend down forever, if the parabola was, but I would cut the x-axis twice, and therefore that's impossible to have no roots and be concave down. Anyway, these parabolas have special names. So for the first one, the red one, it says since this graph is always positive, the quadratic function is called a positive definite function because we're concave up and we have no roots, therefore we're always above the x-axis. Whereas on this side, since this graph is always negative, the quadratic function is called a negative definite function. That's because we're concave down and we have no roots, therefore we're always below the x-axis. So now with all that, we need to know all those terms now to answer the following questions. So it's number 3 in my, that's because I had to delete number 2. Show that the following equations have 2 roots and check if they are rational. Okay, so what's 2 roots? Think about it. Here's the quadratic formula. I just want to remind you. Okay, so here we go. The square root of b squared minus 4ac, and that's the discriminant, all over 2a. So girls, if I want my equations to have 2 roots, that means I need to have the plus and minus going into effect, and that only happens if this still exists and it doesn't become 0. So I need that to be bigger than 0. Remember, if it's less than 0, then it becomes undefined and I have no roots. Okay, so I want what's under the square root to be bigger than 0. So I want the discriminant to be bigger than 0. Now notice, they're not asking you to find the roots. That's when you know you can just use the discriminant as opposed to, say, the quadratic formula. Because you're just showing it has two roots and not being asked to find the roots, you don't need the whole quadratic formula, you just need the discriminant bit. If they asked you to solve the equations, that's a whole different story. You need to use the whole quadratic formula. So let's have a look. The discriminant is b squared, so 8 squared, minus 4 times a, which is 1, times c, which is 15. So that becomes 64 minus 60, which is 4. Okay, so it's bigger than 0, therefore there are two roots. We know that. Now how do we know they're rational? We know they're rational because the discriminant is not just positive, but it's a perfect square, because the square root of 4 is 2, a whole number. So girls, when you put that into the quadratic formula, it's going to become x equals negative b, negative 8, plus or minus root 4 over 2a, which becomes negative 8 plus or minus 2 over 2, which becomes negative 8 plus 2 is negative 6, divided by 2 is negative 3, and negative 5. Now, please understand, that last bit that I did, all of this, I just did it to show you why it has rational roots. It has rational roots because 4 is a perfect square, which means this part here becomes a rational whole number, and therefore my roots are rational. So, you don't actually need all that to answer this question. I'm just trying to explain where it comes from. So, I'm just going to rub all that out to emphasize you don't need it. Now, so to get back to the question, check if they are rational. Because the discriminant is a perfect square, the roots are rational. Roots are rational. Okay, now let's try B. We want to see if it has two roots, so we find the discriminant. So discriminant equals b squared, which is 36, minus 4ac, 4 times 1, which equals 36 minus 4, which is 32. Okay, that's bigger than 0. Therefore, there's something to plus and minus in our quadratic formula. So therefore, there are two roots. Now notice, I really in my question should have said two distinct roots. Anyway, so now that I know they're two roots, are they going to be rational? No, because 32 is not a perfect square, and therefore the roots are not going to be rational. Again, let me show you what that means. If I were to use the quadratic formula, I'd get negative 6 plus or minus root 32 over 2. And that becomes, even if you simplify it, you get 4 eighths of 32. So you get actually 4 root 2. 16 times 2 is 32 over 2, which is negative 3 plus or minus 2 root 2. That's not rational because you got the root 2. Because 32 is not a perfect square, my roots, my final roots, which are those, are not rational. Okay, so again, I'm going to rub all that out to show you don't actually need to do all that working, because I noticed in some students' papers they didn't know when they should just use the discriminant or use the quadratic formula. So, to get back to the question, we can say because discriminant, or 32, is not a perfect square, the roots of the original quadratic equation are not rational. Okay, next question. Find the values of m so that this equation here has real roots. Okay, this is such a popular question in exams, this type of question. So girls, let's just take a moment and think about this. In this equation here, A is 4, B is negative 3, and C is m. M is not a variable, M is a constant. And so C is M, because M does not have any x's attached to it or timesing by it, therefore it's a constant. So that's why it's C. So now, they're saying it has real roots. It didn't give me the number of roots. In other words, the real roots exist, so therefore my discriminant is not negative. What's not negative? Well, therefore the discriminant can be positive, but it can also equal 0 as well. Because even if it equals 0, it'll have one real root, or a double equal root, if you like. So either way, it has real roots. So my discriminant is bigger or equal to 0. So let's find what the discriminant is. Discriminant equals b squared, which is 9, minus 4 times a, which is 4, times m, which is c. So we get 9 minus 16m, and that's bigger or equal to 0. So let's solve that. I might move the 16m over and get less than or equal to 9. Divide by 16, divide by 16. M is less than or equal to 9 on 16. So, girls, basically the values of m that make that quadratic have real roots are these values, less than or equal to 9 on 16. Now, let's have a look at the next question. Okay, this is a very good question. Okay, consider the equation kx squared plus k plus 3x equals 1. Find the discriminant and draw its sign diagram, and hence find the values of k for which the equation has two distinct roots. One thing at a time. We can't apply the discriminant or quadratic formula or anything until everything is on one side of the equation and it equals 0. So let's move the 1 to the other side so it becomes a negative. So we get kx squared plus k plus 3 times x minus 1 equals 0. Only now can we apply the discriminant. Okay, so what is the discriminant? Well, first, let's make a note of what A, B, and C are. A is k. It's right here. B, now a lot of people got confused about this in the exam. B is all of the coefficient of x. K plus 3 is all multiplying by x. Therefore, k plus 3 is b. And now C is negative 1. So we're going to put those in the discriminant. So the discriminant is b squared. So it's k plus 3 squared minus 4 times a, which is k, times c, which is negative 1. So if we expand that, we get k squared plus 6k plus 9 plus 4k, because that's what all of this multiplies to. So finally we get k squared plus 10k plus 9. So that is the discriminant. Now, A. We want to find, I was supposed to first draw a sign diagram. What's a sign diagram? Okay, so what I do is I first factorize it to find my critical values. So I factorize this. Hopefully you can see that it's k plus 9 times k plus 1. And you might have used PSF to do that. Now, a sign diagram, you have like an x-axis or k-axis in this case, and you plot the critical values. Now, from these factors, you would say, if that equals 0, you would say k is negative 9 and negative 1, right? So they're our critical values. So you put negative 9 here and negative 1 here. And we want to know what the discriminant is doing around these values, okay? So we're doing this for the discriminant. So let's have a look. What's a number on this right-hand side of negative 1? Well, we could use 0. So if k was 0, what would we get? If k was 0, the discriminant would be k squared, which is 0, plus 10 times 0, which is 0, plus 9. I'm substituting it in this line here, okay? So the discriminant is 9 when k is 0. So on this side, we can say the discriminant is positive. Now, In between -1 and -9, let's choose a value like -2. If you put that in the discriminant, and you could put it in any line, you'd get the discriminant equals, okay, -2 squared is 4. -2 times 10 is -20 plus 9. I've just picked k as -2 because it's in between -9 and -10. You can choose any value in that range. And there you get a negative number. You're going to get -7. So now we're negative. The discriminant is negative. And now I want to choose a k value on this side of -9. So for instance, -10. Now, I'll just show you, it's easier actually to sub it in this one because -10 plus 9, well, that's -1 here. And -10 plus 1 is -9. So -1 times -9 is a positive, so I get a positive value there. So, that's my sign diagram. So now we think about question A. For what values of k would the equation have two distinct real roots, so different roots? That's when the discriminant is bigger than 0. So let's look at the sign diagram. When is the discriminant bigger than 0? Oh, that's when k is less than 9 here and bigger than -1. So therefore, k is less than -9, and when k is bigger than -1, that is when we have two distinct roots. For B, when does it have two real roots? So in this case, they're not using the word distinct, therefore they could be two equal roots or two distinct roots. That's when the discriminant is bigger or equal to 0. So now we just use the same answer as before, but just put an equal sign, because we also want it to be when it equals 0. For C, a repeated root, in other words, two equal roots. That's another way to say two equal roots. And that's when the discriminant equals 0. When does the discriminant equal 0? That's actually on -9 and -1, because that's what we got from here when we made the discriminant equal to 0. So that's when k equals -9 and -1. And lastly, for D, no real roots and all. In other words, when is the discriminant negative? That's in the middle here, between -9 and -1. When k is between -9 and -1. I didn't put equal to, because that's when the discriminant equals 0, in which case it would have real roots. It would have two equal real roots. But I don't want that. I only want to know when discriminant is less than 0. Okay, so that's how you do that question. And that's those skills we just used are really important for exams. They'll come up a lot. Lastly, okay, question 6. Use the discriminant to determine the relationship between the graph and the x-axis. Okay, a lot going on here. Let's have a go. What is the discriminant of this graph? A is 1, invisible 1, B is 3, C is 4. So here's the formula again, b squared minus 4ac. B squared is 9 minus 4 times 1 times 4. So we get 9 minus 16, which is -7. Oh, that's less than 0. So what does that mean? That means we have either a quadratic that is all above the x-axis or it's all below the x-axis. Either way, it does not hit the x-axis. So that's the relationship between the graph and the x-axis. So therefore, this graph, and when I say this graph, I mean y equals x squared plus 3x plus 4, does not hit the x-axis at all. Now, do you know which one it is? Is it the concave up one or the concave down one? Hopefully you realize that because A here, invisible 1, is positive, so A is bigger than 0, We have the concave up version, so we must have this version here, not that bottom one, so I'm going to rub it out. Okay, it's actually the one above the x-axis, so we can even put in that in our answer. It does not hit the x-axis, and we can even use the words positive definite because it's completely above the x-axis. Okay, so that's a very good answer for A. Now let's try B. Okay. So let's just write down, what is A? A is -2, B is 5, C is 1. So the discriminant is B squared, 25, minus 4 times -2 times 1, which is 25 plus 8, which is 33. It's bigger than 0. So what does that mean? We have 2 roots, therefore we have 2 x-intercepts. So 2 roots, or in other words, which means 2 x-intercepts. Let me draw a graph of that. But wait a minute. Is this a concave up or concave down parabola? Hopefully you realize because A is -2, it's a concave down parabola. So it would look something like this. I don't know if it's on the left or right of the y-axis, but the important thing is it's concave down and it hits the x-axis twice. So we can finish off by saying this graph hits, or intersects is probably the better word, the x-axis twice. And now, you might remember, this is actually called an indefinite function, but that's not really necessary for this answer. They didn't ask about that. But it's good to note that that's an indefinite function because it's in the positive and the negative parts of the y values. Okay, so girls, all of this work now corresponds to exercise 1B. So if you felt this was good and you learned from it, my advice would be to do a few of exercise 1B just to make sure you really understand what's going on.